Hi guys, in this video you're going to look at some ratio questions taken from the past exam papers for Eduqas exam board. Let's look at the first question, which will be non-calculator. A length of wire is cut into 3 pieces. The 2 shortest pieces are the same length, and the longest piece is 3 times the length of each of the shortest pieces. So first imagine you got the wire cut into 3 pieces, 2 the same size, and the last one is 3 times more. That becomes ratio 3, and the first 2 pieces the same size. We're going to mark them as 1 to 1 to 3. So that's a triple ratio. We could have also written it as 3 to 1 to 1. Mark scheme allows you to write them in either order. For what fraction of the original length of y is the longest piece? You can see that is 3. 3 parts out of all, that's what fraction is. So let's add all the parts together, 5, and that becomes 3 over 5. So Lena makes a fruit drink by mixing orange juice, pineapple juice and sparkling water in a ratio orange 3 to 2 to 7. Okay, so what fraction of the mix is water? So first of all, we're going to add all the parts together and show 7 as 7 out of 12. That is a fraction. Next question, Lena pours 300 ml of her fruit drink into a glass. So 300 ml, that's what she makes from mixing all the parts together. So we're going to start by adding all the parts together, which we've already done. 12 parts, because this question is about sharing in a ratio, sharing the total. So 12 parts make 300 ml. And from here, we're going to work out 1 part of the ratio. So that will be 300 divided by 12. So you can use the bar stop method and then work out this division. 12 into 30 goes 2 times, that's 24, and 6 is a remainder. So put the 0 down, got 60 there, 12 into 60 goes 5 times. So 1 part is 25. So we need to look at the pineapple now and see how many parts is there for pineapple. In the ratio, that is 2. So 2 parts times by 25 will give you 50 ml. Next question. The next questions are taken from calculator paper. Let's have a look at the first one. The diagram below shows a piece of string AB that is 8 centimeters long. The string is cut into 2 pieces in a ratio 1 to 3. That means the second part will be 3 times longer than the first one. So altogether we've got 4 parts. We can imagine it dividing that string into 4 parts. That's 1 part, that's 3 parts. So that means we're going to divide 8, the total length of the string, by 4, which will give us 2 centimeters. So each piece is 2, so cut should be made 2 centimeters from A. Okay, next question. The diagram below shows black and white counters. So we need to write what fraction of the counters are black. So we know fraction is black out of all of them. So let's count all of them. 15 in total, black and white, and the black ones 7. So 7 out of 15 we're going to write as a fraction, 7 over 15. Next question, what is the ratio of the number of black counters to the number of white counters? So now we're going to write them in ratio. We don't need to add them together. Black separately, white separately. So 7 black and 8 white. 7 to 8. Let's look at the next question. You've got what's the smallest number of extra black and white counters that need to be added to the diagram above so that the ratio changes to 2 to 3. Okay, so 7 to 8 what we have. We need to change it to the ratio 2 to 3. So we can just try first to do like some trial and error. If we add 1 to black, that gives you 8 to 8. That's 1 to 1 ratio. If we add 2, that gives you 9 to 8. It's not what we want. We need 2 to 3. So we can carry on like this forever, but we need to look for the different method, how to change that into ratio 2 to 3. So what we can do, we can make some equivalent ratios with 2 to 3 here. And how do you make equivalent ratios? You double each number, you triple each number, you times each number by the same number. That's what might help you here. Okay, let's start writing some equivalent ratios to 2 to 3. Double each number becomes 4 to 6. Triple each number, 6 to 9. Times each 2 and 3 by 4, that will give you 8 to 12. Times each number by 5, that will give you 10 to 15. Okay, so which one is suitable? 8 to 12. Why? Because that's the smallest one. 10 to 15 will be like more numbers should be added to both. We can't go for 6 to 9 because we already have 7 black counters. We can't go down. We have to add. So 8 to 12 will be the right equivalent ratio. So we're adding 1 black and 4 white ones. Okay, next question. £87.75 is being shared between Zane and Edith in the ratio 3 to 4. How much money would each of them get? So we're sharing the total here. That means we're going to add the parts together in a ratio. That will be step 1. So we've got 7 parts. And we're going to divide the money by 7 to get the 1 part. So this is a calculator question, so use the calculator here. 87.75 divided by 7 equals £12.25. That is 1 part. So to work out how much each person gets, we multiply £12.25 by 3 to get Zane's part, and £12.25 times by 4 to get Edith's part. And we can double check this by adding the answers together. They should add up to £85.75. So always do that at the end to double check that you've got the parts, work out the parts right. Okay, so that's been checked now. And these are your 2 answers. Okay, next question. Sam and Jody share £366 in ratio 1 to 3. How much money does Jody get? So again, this is a question about sharing the total, so we have to add the parts together. And then 366 divided by 4, but will give us one part in a ratio. So 91 pounds 50. And Jodie's part is 3 of that, so we're going to multiply that by 3. 91.5 times by 3 will give us the answer for Jodie's part. So 274.50. So don't forget to put 0 there because that's money. So let's look at the next question. Maria is 4 years old and she's half of Connor's age. So what will be the ratio of their ages in 2 years' time? Give your answer in its simplest form. Maria is 4, she's half of Connor's age. So how can we write it as a ratio? Four to 8. So in 2 years' time, we're going to just add 2 to both. There will be 6 and 10. And if we simplify it, that means we're going to divide each number by 2 because 2 goes into both. And that will give us the simplified ratio 3 to 5. Okay, let's look at the next question. Alan keeps fit by walking and weight training. The time he spends walking and weight training are in a ratio 4 to 3. 1 month, Alan walks for 18 hours. So work out the number of hours Alan spends weight training during this month. So I'm going to write the ratio first. And one part of the ratio is given to us. It's 4 to 3. And we know what 4 means. That is 18 hours. So this is a different kind of ratio question. When one part of the ratio is given, we know the value. It's just we need to make equivalent ratio. Let's look at the increase from 4 to 18. So we're going to divide 18 by 4 to find the increase. 4 into 18 goes 4 times. 2 is a remainder. So put the dot and the 0 in the remainder. 4 into 20 goes 5. So 4.5 times. So 4.5 times by 4 gives you 18. That's the way of checking it. That means the other side also should be multiplied by 4.5. So 4.5 times 3 will give you 13.5 hours. That is weight training. So he did weight training for 13.5 hours. Okay, let's look at this question, 3-mark question. Rashmi is training for triathlon. The number of hours she spends swimming, cycling and running are in a ratio 7 to 3 to 2. In 1 month, Rashmi trains for 48 hours. So that is the total here. That means we will be adding all the parts together. And then how many more we'll be subtracting here to find the difference between swimming and running. So this question is on sharing the total. So add the parts together. That gives you 7 plus 3 plus 2 gives you 12. So 12 parts means 48 hours. 1 part means 48 divided by 12. Which is 4 hours. So we need swimming and running So swimming is the first one, 7 parts for swimming and 2 parts for running. Okay, so 7 times 4. And we're going to find running now, multiplying by 2 because there are 2 parts in the ratio for running. So you can see the values now, and we're going to subtract to find how many more does he spend swimming. So when you're finding how many more, that means you're going to subtract, take away, and that is 20 hours. Okay, we're looking at the more questions now. They are from non-calculator paper. So this question is on the scale. So a model of a house is made using the scale 1 to 50, and window of the model is 4 centimeters high. What is the height of the window on the actual house? So make sure you understand the ratio. The scale 1 to 50 means for every 1 centimeter on a scale you get 50 centimeters in real life, or in other words, a real size is 50 times bigger. So window is 4 centimeters high, that's the model. And to find the real height, we're going to multiply by 50 because the real size is 50 times larger. So that will give you 200 centimeters. And we don't say big sizes in centimeters, we're going to change it into meters. So 1 meter is 100 centimeters. That means 200 centimeters will give you 2 meters. So the height of the window on the actual house is 2 meters. You should know some of the common heights around or common measurements, lengths, so you don't make mistake and your answer makes sense. For example, height of a door, standard door, is 2 meters. The width usually between 50 and 60 centimeters. Okay, let's look at this next question. Chris makes a door on the model 3 centimeters wide. The door of the actual house is 75 centimeters wide. So 3 centimeters is a scaled measurement. 75 is a real measurement. So scale is the same, 1 to 50. So what are we finding? We're going to see if 3 is correct. So we're finding the scaled measurement. So we're going to divide 75 by the scale, which is 50. That's scale factor. 75 divide by 50. And we can see it's not going to give us 3. If we just divide by 5 first, and then we can divide answer by 10. So that gives you 15. The answer should be 1.5 centimeters. So Chris made the door the wrong width. So it should be 1.5 centimeters. Okay, so next question is also on scale. Scale factor. A wall in the actual house is 2 meters 50 centimeters high. And how high should this wall be in the model house? So remember, the model is 50 times smaller because the scale is 1 to 50. So we're going to convert the whole measurement into centimeters, 250 centimeters, and divide by 50 because we're finding the scale measurement, not the real one. Divide by 50, and that's the same as 25 divided by 5. We're just simplifying the division. So the height of the wall should be 5 centimeters on the model. Next question, we've got two shapes. A company logo is printed on cards and letters. So each line in the larger logo has a corresponding line in the smaller one. The lengths of the corresponding lines are in a ratio of 5:2. So we need to complete the missing words in two statements. So when we're comparing two shapes, and you can see one is enlarged, we need to have a scale factor. So here we have ratio 5:2. It's better if we show them in the form as 1:n or n:1. That will help you to compare them better. Just like we had in the previous question, the scale was 1:50 then. So the missing word is going to be similar here. So these two shapes are called similar because their lines are in the same proportion. For every 5 centimeters on one, you get 2 centimeters on the other. So these are called similar shapes. So remember two words here. Congruent shapes are identical, but similar shapes are we have when the one is enlarged. And the second statement, the larger logo is an enlargement of the smaller logo using a scale factor of. So this is when we make this ratio, change it into 5:2 in the form of n:1. So let's divide each number by 2. And we get 2.5:1. So that's 2.5 is the scale factor. So that means one of the shapes is 2.5 times bigger than the other. Okay, let's look at the next question. One of the lines on the larger logo is 7.5 centimeters. How long is the corresponding line on the smaller logo? So remember the scale factor is 2.5 because we're finding the smaller size, we're dividing by the scale factor. So 7.5 divided by 2.5 is the same as 75 divided by 25, which will give you 3. So that is 3 centimeters. So if you're still confused how you divide this, you just multiply back and see if you get 7.5. So 2.5 times 3 will give you 7.5. Okay, this is a non-calculator question. This is a cooking question. So Sharon is making food for a family picnic. She has 1,800 grams of flour and plenty of other ingredients. So she makes pieces of shortbread using this recipe. So she uses 750 grams of her plain flour to make the shortbread. So how many pieces of shortbread does she make? So this recipe makes 20 pieces. So 300 grams of flour is enough to make 20 pieces. But we got 750. We're going to look at the increase from 300 to 750 and find out the number of shortbread. So we can double first each amount. 300 doubled to give you 600. We're going to double the number of shortbread as well. That gives you 40. And 150 left. That is like half of 300. So we're going to half shortbread as well. Pieces of shortbread, that is 20 divided by 2. And just add up these two amounts. which makes 750 grams. That is 50 pieces. So whatever you do to one side, you do the same to the other. You multiply here, and you make up that 50 pieces. So they are in direct proportion. Both sides increase in the same way or decrease in the same way. So part B. So she needs 200 grams of plain flour to make one apple cake. And she uses the plain flour that is left. Let's see how much is left first of her flour. So she had, how much did she have to start with? At the beginning, 1,800. Yes, 1,800 grams she had. Then she used 750. So now we just need to see how many lots of 200 we can make. So that's fits in 1,050, and that is 5. So she can make 5 apple cakes. Next question, we've got the graph here, which shows annual sales along the left-hand side. We have number of copies in thousands, and horizontally we can see years increasing by 5 up to year 2025. Okay, so Eva uses the graph to predict that about 10,000 newspapers will be sold in 2025. Explain why this is not reliable. So can you see I'm trying to draw different predictions? It can go slightly up, slightly down. So we don't know because 2025 is not marked, and that's quite a lot of years there. From 15 to 25 is 10 years. Anything can happen. So that's, you can give as a reason that maybe 10-year period is too long to predict. It is not reliable. So when you don't have a value and you kind of extend the line, it's called extrapolation, and that is not always true. So how can you explain why this prediction may not be reliable? So value is not shown on the graph, so it's not exact, we don't know, and then 10-year period of time is quite long to predict. Also, if you notice, actually, if you look at other values, they are not quite consistent. They don't change consistently. So, for example, from 2000 to 25, the sharper fall compared to 2005 to 2010. So that is not quite consistent. There is no consistency here. So you don't need to write extrapolation in your paper. It's just I'm explaining if there is no value on the graph, that you just extend the line, and this is what we call extrapolation. And this kind of data is not always reliable. So let's look at the next question. Between 1990 and then 2015, sales of the local newspaper fell from 62,000 to 26,000. What was the percentage decrease? So here we're just using the formula for percentage change. It means find the difference between these two numbers. I'm just writing quickly 62,000 and 26,000 as 62 minus 26. Of course, you can use the calculator here. That's a calculator question. And this going to be written as over the original amount, which is, so that's a formula for percentage change over original amount times by 100. So change is 36,000. Original amount is 62. It fell from 62,000 to 26. And divide that and multiply the answer by 100. Next question, the ratio of adults who read news online to those who do not is 16 to 9. The adult population of the UK is about 52 million. Calculate the estimate of the number of adults in the UK who read news online. So let's write the ratios. 16 to 9. And this is the question on sharing the total, because the total for both parts is 52 million. That means the first step will be adding the parts together. Okay, so this is a calculator question. We're going to divide this by 25, and that will give us 2,080,000. That is one part, and we times it by 16, because there are 16 parts for people who read, and that will give us this number, which is 33,280,000. Okay, next question. Terry is doing his homework. He's trying to find the value of x. X to 2 equals to 30 to 12. And he writes minus 18. So he thinks the rule is minus 18. So first of all, these two ratios can be written separately. X to 12 to 2 and 30 to 12. And you can see actually they are equivalent ratios. That's why they're equal to each other. And we're going to look at the increase from 2 to 12. That is 6 times. So times by 6. And to find x, we're going to do the opposite, divide by 6. So if we do 30 divided by 6, that will give us what x is. So in ratios, in equivalent ratios, we don't add or take away. We divide or multiply. So that was his mistake. He should have divided. You can be specific here. You can write divided by 6, or just write he should have divided. So that's how you find x. X should be 5. Okay, next question is on direct proportion. A factory production line makes 275,000 cans of drink in 5 hours. How many hours would it take for this production line to make 165,000 cans of the same drink? Okay, so let's write it as a ratio, 275 to 5. I'm not writing 1,000, just shortly. And 165,000. We don't know how many hours. So what will be useful here to work out amount of cans made in 1 hour. So let's divide both numbers by 5. That is a direct proportion. It is a non-calculator question, so show your working for 275 divided by 5, which will give you 55,000 cans. And from 55 to 165, so you need to see how many lots of 55. That is 3. So let's just check it. 55 times 3 will give you 165 cans. So that means Terry is right. That is 3 hours. The answer is 3 hours. So tick the option yes. And the question is done. Let's look at the next question. Gemma has her kitchen floor tiled. The pattern is made up of 80 cream tiles and 24 green tiles. So we need to write this ratio in its simplest form. So let's write it down, 80 to 24. So we can divide each number by 4. That will give us 20 to 6. And you can see we can divide these two numbers again. There is a common factor, 2. And that will give us 10 to 3. So this will be the simplest form, fully simplified. Next question. Gemma then has her hallway tiled with cream tiles for the kitchen and hallway. You see, and is marked as in bold, so that's important. The ratio of cream tiles to green tiles is 19 to 3. So there is a ratio of 10 to 3 for the kitchen, and there is a ratio of the tiles 19 to 3 for both kitchen and hallway. Let's write up both of them just to see clearly what we need to do. So for hallway and the kitchen, that will be the second ratio. The number of cream tiles to green tiles. So how many cream tiles were used altogether? So we need to write the actual number for kitchen and hallway. We know the actual number of cream tiles for kitchen only. That was given at the beginning of the question. So we need to find how they're linked, 10 and 19 in both ratios. So how many? 80. So we got 80 cream tiles. That's the actual number of tiles for the kitchen. So that's our actual numbers, which were simplified earlier. And so that means 80 tiles represent 10 parts. So from here we can work out that one part represents 8 tiles. We just simplify 10 to 80 is the same as 1 to 8. And we're going to work out now 19 parts. So one part means 8 tiles. 19 means parts means 19 times 8. 152 cream tiles for the hallway and the kitchen. So that is the answer, 152 cream tiles for the hallway and the kitchen. Okay, we're looking at the next two questions that are from non-calculator paper. The organizer of a teachers' conference provided a buffet lunch made by a catering service. The catering service made a total of 560 cups of tea and coffee, and they were served in a ratio 5:3. So we're going to use these numbers first, and later on we need to find how much was paid for tea and coffee. Okay, let's find out how many teas and how many coffees were served, and then we're going to multiply it by the money per cup. So total 560. So we're talking about sharing the total, add the parts together. 8 parts, divide 560 by 8. That will give you 1 part. You can just do 56 divided by 8, which is 7, and add 0 to your answer. So 1 part is 70. So to work out 5 parts for tea, we multiply 5 by 70, 350 cups of tea. And for coffee, we'll multiply 70 by 3 parts. That is 210 cups of coffee. So we're going to quickly check it and see if they add up to 560. Yes, they do. Good. So we've done them right. And now we're going to work out how much was paid for them. So 350 teas, each is £1, and 210 coffees, each is 150. So £1 each, that's £350 for teas, and for coffee 210 times by 150. So if you multiply by 150, you can multiply by 1 first, find 1, split 150 into £1 and 50p, like I do, and 210 times by 0.5, it means the same as dividing by 2. 210 divided by 2 is 105. Add the answers together. So this is how much you pay for coffees, £315. And finally, we need to add them together to get the total bill for the tea and coffee, £665. Okay, next question. If you want to try this question first yourself, just stop it now, pause it and read it through. Try to solve it and then look at the explanation later. So let's have a look at this. The buffet food was placed on 3 large tables: meat, vegetarian, and vegan. So we had 3 types of dishes. And the teachers chose their food from one of the tables, and the number of teachers per minute who chose food from the table of meat dishes and the table of vegetarian is shown below. So number of teachers per minute. After 5 minutes, 95 teachers had chosen their food. So what we can do, we can work out number of food chosen in 1 minute. So in 5 minutes, 95 teachers chose it. In 1 minute, that's 5 times more. So we're going to divide 95 by 5, and that will give you how many teachers chose the food in 1 minute. So that is 19 teachers. 95 divided by 5 is 19. So 19 teachers. So we know 8 chose meat, 4 vegetarian and we're missing the vegan part. So we can easily work it out from the equation I made. So mark vegan as x, 19 minus 12 will give you the amount of teachers who chose vegan dishes, 7. Let's look at the next question, and that is taken from a calculator paper. A brand of toothpaste is available in 2 different sizes. 87.5 ml tube cost 49 pence and 125 ml tube cost 72 pence. Which size of toothpaste offers the better value for money? So we know that to work out the better value for money, we need to compare these 2 tubes per the same size. So we can compare them per 1 ml each. How much you would pay per 1 ml. If you actually go to the shop and the supermarkets, you can see quite often along with the price, you can see the price per 100 grams or 100 mils for something. That's a better comparison to find a better value for money. So what we're going to do in the first case, you're going to divide both numbers by 87.5 because that will give you per 1 mil. And the second option price, we're going to divide amounts by 125. So 125 mils divided by 125 give you 1 mil as well. So let's work them out with the calculator, and that will give us a clear picture of which deal is better. So the first one cost 0.56 pence, and the second one, you divide 72p by 125 will give you 0.576p. So now just make sure you can compare them right. So let's write them both. So you see the second decimal has got 3 numbers after the point, so we're going to add 0 to the first one, and that clearly shows you that the first price is cheaper. So always compare per the same weight, per the same capacity when you want to find a better value for money. Okay, so next question is on enlargement and scale factor. So you need to understand what scale factor is. So a factory sells paint in different size tins, and the square labels on a small tin has a height of 6 centimeters and on a bigger one 15 centimeters. So we need to complete the sentence. So 6 to 15, that's a ratio of their heights. The large label is an enlargement of the smaller label using the scale factor. So when we do scale factor, we need to change the ratios into 1 to something, 1 to n form. So for this, we're going to divide each number by 6. So we can use the calculator. Let's divide each number by 6. That gives you 1, 2, and 15 divided by 6. That will give you 2.5 on the calculator. So that means the bigger label is 2.5 times bigger than the height of the smaller one. Let's look at the next question. The factory makes orange paint by mixing yellow and red paints. On Monday, they use 66 liters of yellow paint and 99 liters of red paint. On Tuesday, they use 264 liters of yellow paint. So how many liters of red paint was used on Tuesday? So this is a question on equivalent ratios. So the second ratio will be 264 to something. That's what we need to find, the amount of red paint. So let's have a look at the increase from 66 to 264. How many times the number got bigger, so we can divide 264 by 66 on a calculator. And that gives you 4. That means the increase will be 4 times. So 99 for the red paint multiplied by 4, and that will give you the amount of red paint for Tuesday. So 396 liters. Let's have a look at the next question. So this actually, I had to try this question twice because there is a little bit got tricky at the end. 3 friends buy some paint. You can try this question yourself. You can pause the video and try it and see if you get it right, and then watch the rest of the video. So Murphy buys 5 liters of paint. Jane buys 3 times as much. So that becomes 5 times 3, 15. And Alex buys half as much as Jane. So we're going to divide Jane's part by 2, 7.5. So this is okay to have decimal numbers in ratio. You can use decimals. So 5 to 15 to 7.5. And paint cost £4.95. So total paint. So let's work out, add all the parts together. That gives you 27.5 liters. And the cost is £4.95. You multiply it by the amount of liters. And use the calculator. So this is when I got stuck because I couldn't find this answer in the mark scheme until I realized paint cost £4.95 for half liter. That means you have to multiply your answer by 2. So normally when you go to shops, you don't get the prices like that. Something costs per half liter, it costs per liter. And this is probably my fault. I didn't read this properly, but you do. So the answer should be doubled. £272.26. Okay, so this is quite straightforward question. We've done similar one in this video. Let's look at the next question. It's quite a long, wordy question. It's only 3 marks. There are not so many calculations, just a lot of reading. So Mike wants to find out how many fish there are in the lake. On Monday, he captures a random sample of 100 fish and tags them. He then releases them back into the water. On Tuesday, he captures a second random sample of 50 fish and counted the number that had been tagged. So he found out that 10 of the fish in the second sample had been tagged. So 10 out of 50 were tagged. I'm going to make a note of it. And Mike will allow fishing at his lake when there are more than 800 fish. So you may assume that the number of fish in the lake stays the same between the 2 samples taken. Should Mike allow fishing in the lake? So you might think how the sample of 10 fish can help, 50 fish can help him to find the total, but you can. This approach is used in statistics a lot. So whatever percentage you get out of small sample, we can apply for the whole total. So let's have a look then. 100 fish were tagged and out of total. So that means he captured 100 fish, tagged them, put them back in the water. Then next day he captured 50 fish and 10 of them were tagged. So let's simplify this. 1/5 of the fish were tagged. Actually, I'm going to write it as a percentage. That's the same as 20%. We just converted 1/5 into 20. And that means 20% of the fish he caught was, or captured, was tagged. So we're going to apply this 20% to the whole amount, total amount of fish. So assume that if 100 fish represent 20 tagged, what is the whole amount of fish in the lake? So 20% of the fish is tagged in the lake. So we're just going to work out 100%, the total amount. So from 20 to 100, that is 5 times more. So we're going to do the same with 100. And that will give us amount of 500 fish. That looks like sensible answer. So 500 fish in the lake. So that means, should Mike allow fishing? No, because it's not 800 or more. So he should have more than 800 fish in the lake before he should allow fishing at the lake. So we're going to say no, because 500 is less than 800, or there's no 800 fish yet in the lake. Okay, so we need to tick that box. Do not allow fishing. Next question. Nathan and Lucy make and sell wooden items for gardens. And they make and sell benches, tables, tool sheds. So they're given in the ratio 2, 3 to 7. So we've done similar one before. For the fraction, we add the parts together and show them as out of all. So 2 plus 3 we have to add, because that's benches and tables. So 5 parts out of 12, 5 over 12. So his total profit was £18,072. That profit includes selling all of them, all the wooden items. And we're going to work out how much profit he made from selling tool sheds. So we're going to work out one part first. Divide the total profit by total parts. That is 12. And then we'll multiply the answer by 7, because there are 7 tool sheds, 7 parts for tool sheds, and that will give us, so use the calculator here, that will give us £10,542. Next question. Lucy makes and sells planters. Each planter cost Lucy £32 to make, and each one that she sells makes a profit of £80. So before you answer this question, you're going to kind of estimate profit. How much profit is that? It's definitely more than 100%, actually more than double. So we're expecting to get something like over 200% here of profit. Okay, and now we're going to use the formula for how to change a number into percentage. So profit is £80. You need to show this as a percentage of the cost to make the planter. That is 32. So we're dividing 80 by 32 and timesing by 100. And that gives us 250%. That's what we expected here. So profit should be more than 200%. So this question is non-calculator. You can try it before watching how to do it. You can stop, pause the video and watch it afterwards. So we're going to simplify. The first question is quite easy. We've done similar ones in this video. We're simplifying the ratio. So if you see the zeros in both ratios, just drop them off. That means you're dividing by 1,000 in both of them, 45 to 35, but we're going to simplify again because 5 goes into both parts of the ratio. That gives us 9 to 7. If you don't fully simplify this, that will give you only partial marks, but you need to see what the common factors which go into both numbers. So at the end of the first year, Theo and Jenny shared the total profit made by the business in the ratio of their original investments. So Jenny made 21,000 profit. So we know one part in the ratio, 21,000, and we're just going to work out one part. We know one side of the ratio, 21,000. We're going to divide it by 7 to get one part in the ratio, that is 3,000. And for Theo, we're going to multiply it by 9 because he's got 9 parts, and that gives us £27,000. So we need to find a difference. So there is one more step here. Just find the difference between these two amounts, which is £6,000. Should be 6,000 there, not 600. Okay, the next year the business makes a loss and Jenny decides to sell her share. She loses all her profit from the first year and 3/10 of her original investment. So we really need to look at all the parts in this question to find out what numbers we're going to use. So first we're going to use the profit at the end of the first year. That is 21,000. And then 3/10 of original investment. Original investment is in part A, that is 35,000. So we're going to find 3/10 over 35,000. Drop the 0 there, 3,500, and then times by 3. You can do 35 times 3 and add 2 zeros to your answer. This is a non-calculator question, so show all your working. Simplify it as much as you can. When you multiply, divide, you add zeros at the end, for example. So it's 10,500 here. And so we need to calculate both amounts together. Add them together. We need to find the loss from both and add them together, and that will give you 31,000. And that should be 500 there, 10,500. So 31,500. Okay, let's look at this question now. It's a non-calculator question. A catering company made 40 trays of sandwiches for a party buffet. Each tray contained the same number of sandwiches. They made trays of egg, trays of cheese, and trays of meat sandwiches in a ratio 1 to 3 to 4. And we've got second part. It's quite lots of numbers in here. We're going to look at the first part first. Let's just have a look actually how many sandwiches we have on one tray. So they are in a ratio 1 to 3 to 4. So we have 3 types of sandwiches on each tray. They are given in a ratio of 1 to 3 to 4. And we're going to add the parts together. So 8 parts on one tray. And 8 parts actually on 40 trays. We've got 40 trays of them. So we're going to work out one part from here. 40 divided by 8, 5. So one part is 5. That means 5 eggs. 3 parts of cheese, 3 times 5, 15. And 4 parts of meat, 4 times 5, 20. So these are the actual numbers now, or 5 egg sandwiches, 15 cheese, and 20 meat. So 40 sandwiches per tray we have here. So if we want to work out now all the total number of sandwiches, we're going to multiply each by 40 because we've got 40 trays, and that will give us the total amount of egg sandwiches, which is 200, the total amount of cheese sandwiches, which is 600, and the total amount of meat sandwiches, which is 800. Okay, now we're looking at the second part of the question. At the end of the party, 20% of the egg sandwiches, 10% of cheese sandwiches, and 25% of the meat sandwiches were uneaten. So we need to find the amount which were not eaten. So let's find 20% of 200, that is 20, 10% double for 20%, 40. 10% of 600, you just divide 600 by 10, that's 60. And for 25% of 800, just find a quarter of 800, which is half, and half it again, which is 200. So we've got the amounts of sandwiches. Let's add them together. 300. So we've got in total 300 uneaten sandwiches. But what I missed out as well here, how many questions says how many trays of sandwiches were uneaten, not how many sandwiches. So we know each tray, we're just going to work out, we already know how many sandwiches we had on one tray. You can see from the picture that is 5 plus 15 plus 20, 40. So we're going to divide 300 total number of sandwiches by 40. So we've got 40 sandwiches per tray. And that will give us how many trays we have. So divide by 40, we can just simplify this division. We do 30 divided by 4. And again, simplify this by 4. We're going to half 30 and half it again. So half of 30 is 15. And half of 15 is 7.5. So this is the answer, 7.5 trays of sandwiches. Let's look at this question. It's a bit tricky question. It took me a while to do it. It's actually very simple, and it's not so many steps in here. It's just hard to work with 3 lots of information here. So it takes 2 park keepers 1 hour to weed 2 flower beds. It's a non-calculated question. 3 park keepers. For 3 park keepers, it takes 2 hours to prune 6 trees. At 9 o'clock one morning, 5 keepers start work as follows. And you've got the table, information in the table. So 2 park keepers weed 2 flower beds, and 3 prune 13 trees. So this table is a bit misleading because you think you're going to use that information, but you actually look at the second part of the question. It says when one activity has been completed, all the park keepers work on the other activity. That means all 5 of them start working together. So in the first hour, 2 park keepers weed 2 beds, flower beds, and 3 park keepers work for 1 hour, the same time. For 1 hour, they prune 3 trees, because we just divide 2 hours by 2, 1 hour, and 6 trees by 2, 3 hours. This is what is done in the first hour. So 5 of them work, but 2 of them weed the flower beds, and 3 of them work for 1 hour and prune 3 trees. So after the first hour, they work together on pruning the trees. So 3 trees been pruned already. So 13 minus 3 will give you 10 trees left. So now 5 of them should prune 10 trees. So let's write the ratio and the rate, how they work from the first from the question. We have this information. 3 park keepers work 2 hours and they prune 6 trees. What do we need to find? How long it's going to take them for 5 people to prune 10 trees. So let's write all these 3 lots of information next to each other, but we usually work with you have to work with 2 at the same time. So 3 people, we're going to work out how many trees it's going to take for 1 person. So 3 divided by 3 is 1, and 6 trees divided by 3 is 2. So number of hours stays the same. Okay, so 1 person, it takes 2 trees to prune in 2 hours, and then from 1 we're going to move to 5 times by 5, So 5 people. And if we multiply the other sides, that's also times by 5. That gives you 10, exactly what we need. So the amount of hours stays the same, 2 hours. So it takes 2 hours for 5 people to prune 10 trees. So 2 hours is not the answer, it's just part of your answer. Remember, in the first hour they work together, and so we're going to add another hour to it. So 1 hour and 2 hours here. So altogether they need 3 hours to complete the job. Next question, a garden center sells packets of flower bulbs. This is a non-calculated question. And so we've got bluebells, daffodils, tulips. Let's write them in a ratio as B to D to T. And we know X packets of bluebells. We're going to put X there for bluebells. And twice as many packets for daffodils. We can put 2X. So we're using algebraic method here. And for tulips, we're going to put 5X. If you don't like working with X's, we can just write them as 1 part for B, bluebells, 2 parts for daffodils, and 5 parts for tulips. So altogether, that represents 320 packets. So we're talking about sharing the total in a ratio. So we're going to add the parts together. That's always the first part, first step when you're sharing the total in a certain ratio. So add the parts together. 1 plus 2 plus 5 give you 8. And 8 parts mean 320 packets. So we're going to work out the 1 part from here. 320 divided by 8, which is 40. So we worked out 1 part. That is exactly what bluebells are. So 40, and we're going to multiply it by the money now per packet. So 40 times 6. For daffodils, we're going to multiply 2 lots of 40, 80, multiply by the money by £5. And then tulips, we have 5 parts of tulips, 5 times 40, 200. And we're going to multiply 200 by the price, by £10. So they all got different prices, so make sure you multiply them by the prices shown. So the first bluebells will cost £240. 80 times 5, you can do 8 times 5, 40, and add 0. And 5 times 200 times 10, £2,000. So add them all up, and that will be how much money the garden center takes from selling all these items. £2,640. Let's look at this non-calculator question. Anna and Tom work part-time at the garden center. The number of hours they each work is in the ratio 3 to 5. 3 to 5. We also know that Tom works 25 hours. So we need to find Anna's part. So original ratio is 3 to 5. Okay, let's just look at the increase. This is a question of equivalent ratios. How can we work out the missing part? So the increase is 5 times more. That means for Anna is going to be the same. 3 times 5. She gets 5 times more. That is 15. So Anne gets £15. And Tom 25. 15. No, numbers of hours, not pounds, it's number of hours. So Anne gets 15 hours, works 15 hours, Tom 25 hours. So we need to find the total number of hours. They both do. And add them together. 15 plus 20 is 40 hours for both of them. Anna earns £156 each week. So how much does Anna earn per hour? So per hour means we're going to divide. We're going to divide 156 by the number of hours she does. So we know from the previous question that is 15 hours. So 156 divided by 15. So you can work this out in 2 steps. If you don't know how to divide by 2-digit number, you can divide by 3, then divide by 5, because 3 and 5 are factors of 15. We can just break it down into 2 steps. So let's divide 156 by 3. That gives you 52. That's a short division. And then divide 52 by 5. One way of dividing by 5 is actually dividing by 10 and then doubling the answer. So when you divide by 10, you just get 5.2. The point moves one place to the left in this case, and times it by 2, you get 10.4. As a money, we're going to write as £10, £40. Okay, next question. Tom gets a pay increase of £1 per hour. His hours remain the same and he now earns 175 per week. So how much did Tom earn per hour before his pay increase? Let's just work out normally. So he does, and then we will find increase. So Tom's hours is 25 and he earns £175. Let's divide 175 by 25. So you see how many lots of 25 go into 175. Just multiply here. Use a couple of numbers, 6 by 7 times by 6 times. You'll see 7 lots of 25 make £175. So, and that's actually £1 less. That is £6. So we have to subtract £1 from 7. So he earned £6 before the increase. Let's look at this question with two-way tables. It involves fractions, working out fractions, and writing all the missing numbers in a table. So there are 45 swimmers in Top Swim Club. All swimmers are learning butterfly and backstroke and are asked which they prefer. So 3/5 of all swimmers prefer backstroke. So let's work out 3/5. 3/5 of 45. So we're dividing 45 by 5 and timesing by 3 should be 5. Yes, 45. That give you 9, and 9 times 3 will give you 27. So 27 swimmers prefer backstroke. That goes in here, 27. The number of juniors is double the number of seniors, so it can be written as a ratio 2-to-1. So 45 swimmers can be written as in ratio 2-to-1. So let's add parts together, 3, and divide 45 by 3. That will give you one part in the ratio 15, which is seniors, and juniors gonna be double of that, 2 parts, 15 and 30. So they do add up to 45. That's correct. So we're going to work out 1/6 of juniors, 1/6 of 30. So 1/6 of 30 is the same as 30 divided by 6, which is 5. So now we can work out the other parts in the ratio. 30 minus 5 is 25. 27 minus 5 is 2, so we just worked out seniors. 15 minus 2 is 13, and for the total we just add 13 plus 5, 18. So all numbers are done now. So now we can answer the last question. Final question, work out the proportion of swimmers who are seniors and prefer backstroke. So proportion basically means find the fraction. Swimmers who are seniors, let's have a look at the senior part in table. Senior, let's go across, and backstroke, that is the number we need 2. So just show it as out of all the swimmers, which is 2 over 45, and that will be the right answer. So we've done similar question in this video, so just watch it quickly how it should be done.